Yeah, hello everybody. Thanks for joining. We're just waiting for a few more people to join, so we'll get started in about 2 minutes' time at 1 o'clock Central European time. Okay, so it's 1 o'clock Central European time, so we'll get started. Hello everybody. My name's Paul Brett. I'm responsible for Cubro's business in the UK, Ireland, and Middle East, and I'm your host for the webinar today. I'm joined by Herbert Etlinger, who's actually a founder of the company, but is also responsible for our product solution and engineering teams. As you know, the agenda today is predominantly focused into the technology of 400 gig network visibility, and Herbert will be covering the majority of the agenda. So we'll be talking about 400 gig technology basics, the considerations for 400 gig technology, and also then some of the solutions and capabilities that Cubro including our network packet broker product, which I believe I'm fair in saying is the only available advanced network packet broker, a 400 gig solution available in the market today. I'm just going to briefly introduce Cubro to anybody that's not familiar with us, and I just wanted to highlight also the benefits of our solution, so you can just bear those in mind as we move through the technology presentation. We'll have a Q&A at the end, but obviously feel free to ask any questions that you have as we move through the presentation. We'll also be posting some polls and handouts as well in the chat window there as we go. So to move forward, who are Cubro? So Cubro, we are leading manufacturer and global supplier of network visibility solutions. Our customers include many of the world's largest service providers and many of the world's sort of household names and largest private and public sector enterprise organizations as well. And we also partner and work with many leading, world's leading technology specialists, people like Nokia, people like Ericsson, Expo, Polystar, Fortinet, leading technology vendors in other spaces as well. According to Omdia, we are, by market share, we're number 3 in EMEA, number 2 in Asia Pac, and number 5 globally now. We expect that to improve over the next 12, 18 months, actually, as we start to deploy some fairly significant projects that we're currently working on in the US, actually. Cubro, we're an Austrian company. We're headquartered in Vienna. We have offices in Japan, Singapore, Graz, and the US. And we've been around for about 20 years now. In terms of products, they fall, the products that we manufacture and supply fall into 4 broad categories. Working from left to right, there's a range of taps and bypass taps. They support both copper and fiber media and support speeds up to 400 gig. We have several ranges of network packet brokers that support speeds up to 400 gig and traffic up to layer 7. Then we have probing capabilities, which are probes that are able to generate and optimize CDR metadata, and probes that can generate and optimize NetFlow and IPFix metadata. And then we have several software products, which include the optimization software, deep packet inspection capabilities, and operational management software. The final slide that I'm going to cover before I hand over to Herbert is really just to, as I say, to highlight what we see is probably the benefits of our approach for 400 gig network visibility solutions. Many of our customers are either deploying or planning to deploy 400 gig networks, but they, of course, need to continue to be managed for performance, for security, and for planning and analytics and so on, and use a range of tools to carry out that function. And of course, the function that the Cubro solutions provide is to deliver a copy of the relevant 400 gig traffic to those network tools. So the first of the values that we deliver as part of our approach is a managed investment profile, because you can continue to use those existing network tools that are in place. Our technology is able to mitigate the disparate speeds between existing tools that could be equipped, let's say, for 10 gigabit or 40 gigabit or 100 gig networks, and allow them to manage 400 gig networks. In combination with that, our 400 gig solution, as is always the case actually across a range of Cubro solutions, we offer a low cost of ownership, typically 30 to 50% lower cost of ownership Cubro solutions compared to our major competitors. And when you combine those two factors, we're able to offer a smooth technology migration, but a managed investment profile. So you're able to invest in 400 gig technology when it's required by the business and in line with business needs. It also means that we can minimize network disruption because those network tools can be migrated over time to 400 gig. You don't need to do a forklift upgrade of existing network tools. Because of the sort of latest ASIC technology that's deployed within our products, we're able to reduce the network tool footprint, power, and cooling requirements by reducing the quantity of traffic by filtering, aggregation, and other advanced features that we're able to carry out and then send to those relevant network tools. And the final benefit I would suggest is the future-proofing capability of Cubro solutions. And I mentioned we are the first and only advanced network packet broker, 400 gig network packet broker available today. However, we've obviously built into that future-proofing capability. And because of that latest ASIC technology, which gives us, or two of the benefits of that is a broader and richer feature set and higher performance and capacity capability. So from a performance point of view, we have a very high headroom in terms of expansion for performance and capacity. And we have the ongoing ability to support very complex overlay networks because of that feature-rich capability of the product. And of course, those overlay networks are becoming increasingly important in those high-speed network environments. So those are really the highlights of some of the benefits that we offer, and really sort of completes what I was going to cover. I was going to hand over to Herbert now to take you through the technology part of the presentation, and I'll come back at the end and summarize and just host the Q&A. Herbert, over to you.
Yeah, super, perfectly. Okay, super. Thanks, Paul. Thanks to everybody joined us today. Look, I need to share my screen because to see something, just give me 1 second. And yes, I think you should see it now. Okay, so yeah, as said by Paul, yeah, perfect. Thanks, Paul. So I'm leading actually the technical support and product engineering team, and being since our day zero part of Cubro, so to say. So the last 20 years spent my time here. Okay, it's not getting boring, believe me. Good. Today, we talk about 400 gig, and what we are going to do is, first of all, just I want to give you a little bit of an insight. What is 400G? Okay, and how it's different to 100G, for example. And later on, then we will talk about optical tapping, breakout solutions, and of course also about the advanced network packet broker. What is so special in our solution? Okay, but first let us start with some basics so that we are all on the same page. Okay, doke. Good. Let me also use my pointer. So here we are. Look, it's just a very short introduction of 100G, and on top you see these three pictures. That is just a drawing of how very typical 100G interfaces look like. And basically, just to remember here is 100G is based on 4 times 25 gigabit. Okay, that's the fundamental, let's say, giving them the 100 gig, of course. And modulation, which is very important, is we are using non-return to zero modulation. In the next slide, you will see what that means. Okay, so basically what we have is here electrical rate and line rate is the same. This is because of the modulation. Okay, compared to 400G, is what we see in the next slide is we are using in 400G is using the PAM4 modulation. PAM stands for pulse amplitude modulation 4. And 4, what the 4 means is that in an NR set, like the 100G is used, the amplitude can have 2 states, either light or no light. So 0 or 1, very easy. But in PAM4, the light can have 4 states. It can be no light, a little bit of light, a little bit more light, and full light, so to say. And what that means is in a PAM4 signal, actually the data rate is 50 gig, but the symbol rate is only 25 gig. Okay, so we're making this kind of trick to reduce actually the requirements for all the synchronization, transmitters and receivers. Okay, so that's the fundamental first difference is the modulation. Okay, so in 400 gig, always PAM4 is used. And this looks actually like when it would look like on an oscilloscope. And one thing may be very clear already, when you took a look to NRZ 100 gig, there is rather a difference between a 1, which is here on top, and the 0. So that's your eye opening or margin we have. When you take a look to PAM4, you see this eye opening is completely different. So this difference between the different states is rather small compared to here, which is rather big. Okay, and therefore the signal to noise ratio is reduced when we are using PAM4. And one thing to overcome that is in the 400G, there's always has to be used FEC, forward error correction. So what is forward error correction, which is mandatory in 400 gig? In 100 gig, it's also mandatory for some of the interfaces, but not all. Yeah? So let's say it like this. But in 400G, it's always mandatory. And FEC, what FEC means basically is that you have errors and you know that there are errors, but you will correct after transmission for that. That is FEC. Okay. And the FEC mechanism actually is a little bit different. So there's some Reed-Solomon coding, which is a little bit different in the 100 gig and in the 400 gig. So the 400 gig is just a stronger forward error correction. So it can compensate for more errors. So please be aware, there's always errors on the line, but not on the client side because we will compensate for that. And maybe interesting enough is when you look at the 100 gig, the total bandwidth we are transmitting when FEC is enabled, which is an option, as I said, for most of the interfaces, is about 103 gigabit. In 400 gig, the total bit rate is 425 gig. So we are using more overhead for the error correction mechanism. Okay, just to, when you talk about FEC, in 400 gig, no discussion about FEC. FEC is mandatory. Okay, so just to understand that point. Good. So now taking a look for the optical transceivers. And when we take a look to 400 to 100 gig, it's usually using 4 lanes. So this is the 4 times 25 gig we said at the beginning. And everything is running with non-return to zero code. So 4 times 25 gives us the 100 gig. The 400 gig requires 8 lanes. So not the 4. It requires 8 lanes. And if we do the calculation, then we can have 8 lanes. Everything is running in 50 gig, but with PAM4. Okay, and that gives you the 400 gig. That is actually the background. And inside the optical module would look like this. So if 8 times 50 gig in one direction, and we're receiving 8 times 50 gig in the other direction. And now looking at the transceiver, you all know the QSFP28, that's the transceiver, which is mainly used in the 100 gig. And then there's a new standard, which will come in a second. It's the QSFP DD. DD stands for double density. Okay. And actually, they are compatible mechanically to each other. Okay. But you see, the QSFP DD is just longer and is double contacts here. Maybe one important point to remember here, typically QSFP28 has a power consumption of 3.5, 4 watt, let's say, but 400 gig transceiver is 12 watt. So, okay, so it's quite something that this device has, yeah. So we'll take a look to these two, of course, in more detail, but 400 gig, usually it's the QSFP DD. There's also other transceiver types, which we'll touch in a second, yeah. Okay, but just to remember, okay, the DD is double density. It's just deeper, so to say, yeah. Okay. So in terms of interface standards, you maybe remember in 100 gig, we had 100 gig SR4, 100 gig LR4. So what about 400 gig now? 400 gig exists in different variations, of course. So here they are all listed. The red ones are maybe the ones we see more popular, let's say. Of course, there's many others, of course, but nevertheless, so the red ones are the ones which basically widespread as far as we see. And we are going through some of them, what they actually mean. But you see, it's for single mode, it's for multi-mode fibers, it's different distances, and very important is also it's completely different connectors, optical connectors, as we will see in a second. And here, there's just a little bit of a summary again. And for example, when you take the 400 gig SR8, okay, look, this is actually multi-mode fiber, but it needs 8 pairs. You might remember the 100 gig SR4, that actually needs only 4 pairs of fiber. So the SR8 needs 8 pairs of fiber. So completely different. Also, when you think about if you have to use an optical splitter, of course, it's completely different optical splitters because you're needing more fibers. Okay, and this is just a summary, what connectors you have. And also, there's one of the points which is, it says here typical budget, and I mean optical budget, which means the transceiver can handle between TX power and sensitivity RX power. And it says typical. And that's one of the major issues we usually face, that the typical value, yes, maybe you are even lucky and get much better than typical, but you can even have much less than typical. We will come to that point when talking about optical splitting, of course. Then this becomes an issue and needs to be evaluated. Okay, so these are the most popular standards as far as we have seen until now. Of course, there are others, as I said. So transceiver types, I mean, this point we covered already. So you see, there is different. There are different standards. There is the CFP8, there is OSFP, and there's the QSFP-DD, which we believe this is the most popular one. Of course, there's others, but to be honest, I never came across others, only this DD. And also our product, like the packet broker, is based on that type. Okay, but here you have just a small summary of what maybe you can came across. Okay, so here's again this comparison between the 100 gig QSFP28 and the QSFP-DD for the 400 gig. And the main advantages of the DD, it's backwards compatible. Okay, so usually the 400 gig QSFP-DD supports also 100 gig mode, so you can use as 100 gig, and also mechanically you can change them. Okay, so the only difference is QSFP-DD is a little bit deeper, so it will stand out more from the front panel, but basically it's compatible. That's the good news, as we have it seen here. So here everything is the same, but it's a little bit deeper. And of course, be aware it just needs a lot more power. Okay, so that's one of the important issues here. And that, of course, is the driving factor for the power consumption. Okay, one question we come across very often, and that is also what Paul said at the beginning, that we want to make sure or give you solution that you are having maybe 100 gig monitoring product, but now you're getting 400 gig switches infrastructure. So how can you use your 100 gig monitoring probes? And that is called actually breakout mode. Breakout means that you split from a high speed signal, 400 gig, into smaller ones. For example, very often you have a 40 gig port, but you want to use them as 4 times 10 gig. That is called breakout. Or you have a 100 gig port and want to split out to 4 times 25 gig. When we talk now about 400 gig, yes, it's also possible, of course, to split the 400 gig into smaller values, but there are certain things to consider now. And yeah, this is actually just a picture of what I talked about. Is here you have the 40 gig, for example. This is the 40 gig module in a switch. And then here you have the breakout cable, which goes from this MPO connector to 4 times LC. And here you could connect your SFPs. So 10 gig connectivity. That's, as long as you're talking about 40 gig and 100 gig, this is a very easy, nice solution. Okay, so very cost effective, of course. Yeah, by the way, I mean, people who know me, I mean, this cable here, this is how it looks like. Okay, this is the cable. I'm not a fan of this cable. Why? Of course, because there's a Cubro box, breakout box. It's much better to use breakout box. I will tell you later what breakout box is, but just to remember already now, breakout box means these are breakout cables, but in a metal box. And the cabling becomes then more ruggedized. Okay, so just to remember, yes, if you have use breakout solution, yes, you can do with breakout cables perfectly okay, but much better breakout box. It's the same functionality, but more ruggedized. Okay, so this is breakout mode. So we know now what breakout mode is. As we said, 100 gig, 40 gig, very simple. What about 400 gig now? The 400 gig is, we have to consider a few things. Remember, a 400 gig uses a completely different modulation than the 100 gig. We're using PAM4 and the other one using NRZ. First point we need to consider. What that means actually is that a fully passive breakout, that means just using a cable only, like we have seen before, or a breakout box, is not possible with 400 gig. You always need to have some active adaptation, because remember, the modulations are different. So if you come with a PAM4 modulation in a 100 gig transceiver, standard transceiver, I mean, then it will no link, the link will not be up, never, because it's completely different. There is a way around it, of course. People always try to find solution for that. And the solution actually is this one, that now there's a new kind of 100 gig transceivers who are looking like this. What they actually do is they are taking the 25 gig NRZ, like we have it, and then inside there is a gearbox, let's say, inside transceiver, I mean, and the transceiver makes this adaptation. Okay, from the NRZ modulation up to PAM4 and so on. Okay, so this is the trick. But what it means is it's not fully passive solution. So you need to change existing 100 gig transceivers. Okay, and that is mentioned here is actually you need new 100 gig transceivers, like they are called 100 gig DR1, FR, or whatever. Okay, so that means once you're going for a breakout solution and you have an existing setup, it might happen that you need breakout cable. Okay, still needed most likely, but most likely you also need to change your 100 gig end. So if you have monitoring probe that works with whatever, then most likely you need to go and buy a transceiver like this, which is doing like that. Otherwise, the breakout is not going to work. I think on the next slide that should be explained. Yes, here it is. Okay, so for example, solution from DR4, 400 gig. If you want to use the breakout, you have to use here FR QSFP28 or DR1 QSFP28. So that point also needs to have some adaptation. So these transceivers includes the gearbox. Okay, and then you have breakout solution. Right. Of course, as we said, you can use the breakout cable, but we said already, better to have it in a box. Okay, but same concept as before. But it's not fully passive, you're saying, because you need to change the 100 gig end if it's already existing. Yeah, of course, if it's not existing, then it doesn't matter. Good, this is breakout. So now that we understand the 400 gig modulation, what are the problems and the breakout, let us take a look, a very brief look to the tapping. What issues we are seeing here. And one issue is, for example, because people are always asking, hey, can we use the same tap? We have the tap already. Yeah, sometimes it's possible to use the same tap depending on what the interface standard is. We know we have now 400 gig SR8, and SR8, the connector is still MPO connector, but this is 16 pins. When you're using the SR4, basically we use only 8 pins, and the connector itself has 4 in the middle which are not used, so it's 12 pin connector. So these two, of course, are not compatible. So when you have splitter for SR4, it cannot be used for SR8. It's completely different number of fibers. So this is one of the points we need to consider. Okay, so it's different connector for the SR8, and this is SR4 100 gig. Okay, of course, I wouldn't tell you if there's no solution. Yes, we have a solution, of course, and we have a tab for the SR8 tapping. Okay, so that's fine. This is 4 links here. The one thing I want to highlight here, this is a multi-mode application, and I really have to strongly emphasize, I know people will ask about, hey, can we have it with a 70-30 splitting ratio or anything different than 50-50? And I have to say, no, don't do it. Don't ask it even, because the budget, the optical budget is so tight. So whenever you change something and uh, um, different to 50-50, then the problems are, I can guarantee you, that's not going to work, or it's always working on the very much of the edge. Okay, so it's multi-mode, 400 gig, 50-50 is perfectly okay. It's working, it's verified, has a nice margin, of course, but if you go for 70-30, I guarantee you that the monitoring outputs are not going to work. Okay, and typical deployment would be actually looking like this. So here you have your switch, here you have your router, let's say. So this is the live link. Light is running through in both directions. Then we have 2 monitoring outputs, one from west to east traffic and the other one for east to west traffic. And then we go to packet broker, and then we terminate it there. And that's it. Yeah. So just this packet broker and 2 of these SR8 transceivers installed here. And of course, then you can do some aggregation, filtering, but we see in the next slides. Okay, but this is typical deployment. What about other standards? Because what we found also getting very popular is the so-called DR4. There's also XDR4, PLR4. They all look the same, looks like this picture. It is actually using single mode fiber, but MPO connector. Yeah, so multi-fiber. And the difference between them is very small. It's just the distance. So they're offering higher output power, a little bit better sensitivity, but basically they are completely the same. DR4 and XDR4 and PLR4, they're completely compatible to each other. Okay, and how we can do that? And here the good news is Cubro always had a tap to tap that kind of single mode MPO connector system. Okay, so what we have, the tap looks the same as the other tap before, but it's different inside because it's single mode, and this is using not the 16 fibers inside, but 8 fibers inside. And the good thing is, once you have this tap installed, and maybe today you are running a 40 gig or 100 gig, then you can also use it for 400 gig because it's the same technology behind. Okay, but it's for single mode. It's a different concept that the SR8 you saw in the slides earlier. Okay, so this is single mode, we said. I still am saying here, I would recommend you 50-50. Also, we have tried, of course, 70-30 is possible, and also 80-20 is possible. So in the lab setup we are using in our testing and simulating some insertion loss, also these 2 are working. But please, when you're going for that, please consult with us. Yeah. just to have this optical budget discussion, not to run into the mistake that something is not working. Okay, but you see, there's a tab also for these single mode MPO systems. Typical deployment looks just the same as before. Of course, same is the tab, but it's 8 fiber tab, not 16 fiber tab. And of course, you need different QSFPs, DD on the packet broker because they are single mode. Okay, so this is one thing. So we have also, you see, yeah, not a miracle. And the last one is the so-called FR4 LR4. LR4, here you see it's just a single fiber on the output, and how it's done, you're having every of the signal using a different wavelengths. Okay, for example, it's using 1300 nanometer, the next one is 1310 nanometer, and so on. Okay, and typical connector, only connector that is used is an LC connector. So just everything the same as with 100 gig, 40 gig, or 10 gig single mode. They are actually the same. And for the tapping, yes, there's also good news. Any tap you bought from Cubro with LC, so standard LC taps, which you may be using today for the 1 gig only or 10 gig, that also will support the 400 gig. Okay, so it's the very universal solution for any bitrate. Why is that? Of course, TAP is completely transparent and it doesn't care if this is a 400 gig modulation, if it's 100 gig, if it's Ethernet, if fiber channel, whatever signal format it has. Okay, so it's always the same. Again, it's the same statement as before. 50-50 is recommended, but you also can say, yes, others, there's a good chance that they really work, but needs really good evaluation of the optical budget available. Okay. Yes. By the way, because I had question from customer, they asked me, is it also working for ZR4 standard? ZR4, I haven't mentioned before, ZR4 is for the very long distance. And that works not on 1310 nanometer, it works on 1550 nanometer. Okay. Yes, these tabs are broadband. So they work also for 1550. It's the same tab. There's no difference to us. Yeah? If it's a 1310 nanometer or 1550 nanometer. So also possible. So tapping, hey, not so actually. It's easily possible. The only thing you really need to consider is the SR8, this multimode transmission, that we have more fibers. So usually that needs new tapping, of course. Yeah. All the rest, there is existing tapping solutions that can be reused if already installed. Okay, that's typical deployment actually, how it would look like. Same, always the same as before. Just remember, of course, need a different QSFP at the packet broker to terminate that signal. Okay, tapping summary. Yes, there is full range, of course. They are all fully passive. So never mind with Cubro if there is if we talk about 10 gig or 400 gig, that doesn't matter to us. Yeah, so there's no, no difference in that. Right, and now, of course, coming to the next point is, now we have tapped the signal. So we have a copy of the signal. Perfectly okay. But what we are going to do now? Yeah, usually we have to feed it to a network packet broker or an appliance or whatever to process the packets. Okay, and that we come to the next point. Let's talk about the packet broker. What do we have and what things needs to be considered? Good. So recently, some month ago, we have launched a new product, EXA32400. Yeah, why it's the name? It's 32 ports of actually 100 gig, 400 gig advanced packet broker. Okay, so that's the reason why it's called 32400, because we also have 32100. Okay, it's a smaller brother, let's say. And the key message actually behind that is, I mean, it shows actually, or it proves also the statement that Cubro and we are really concentrated on this high-speed, state-of-the-art network visibility. So we're not stopped at 10 gig or 40 gig or 100 gig. Yes, no, we want to drive this market. And what we do have with this product is that new development is, if you look at these key points here, I mean, for me, of course, but yeah, I'm not the customer for it, to be honest. For me, it's best in class 400 gig network packet broker. And this is the next slides. I hope you agree on that with me. Okay. So let us just go through. This is how the box looks like. So 32 ports of, they can be configured 100 gig or 400 gig. Every port can also be used as 4 times 10 gig, as 4 times 100 gig. That gives you 128 of 100 gig ports. And remember, this is just a 1U chassis. Okay, so very high port count you can achieve. It's actually, these are the cornerstones. It's about 25.6 terabit per second throughput, which means is a non-blocking architecture, means every port can be used as TX or as transmitter and receiver at the same time. So quite something. And what many people like, and I also like, is that all ports are included. So we don't have any, how to say, confusing license system that at the end you don't know what you have to buy and very complicated quotations. No, it's only one line. Everything is included. All the features I tell you, all the functions, all the ports are always included. And also maybe an important point is we are open to third-party transceivers. So of course, Kubo can deliver you the QSFP DD. Yeah, no issue of that. But if somebody has a deal maybe already for transceivers, there's no need to go with Kubo or whatever. So right, of course, be careful, maybe not buying the cheapest ones and low cost and second-hand QSFPs. So still should have some quality, of course, yeah, because that's the interface to outside. But nevertheless, there's no license or blocking. So we are open to that. Okay. In terms of the highlights, and we don't need to go through all of these points, and just remember here on this side, you see the very general features, how to operate the unit and what kind of supervision it uses, like SNMP and this kind of stuff. More important for me as an engineer, let's say, is the right side. On the right side, these features, and some of you maybe know the Cubro advanced packet brokers. So all the features we have with the 40 gig and 100 gig, we have the same features also for 400 gig. So we are using, how to say, maybe best ASIC available chipset, just to allow customers to have these functions. Someone could say, hey, we could just simply use an aggregator, very dumb, lower cost device maybe, which only does aggregation. We don't believe in that idea. We believe in the idea that there's 400 gig network, you need to have maybe complex filtering, and that filtering should be possible with the packet broker. Not that we are saying, hey, let's do the aggregation, then we feed everything to a 100 gig packet broker, and then we do everything there. We believe this is not a good idea because you easily will overload the 100 gig box. You will have these traffic bursts, then you will lose data. Very complicated operation. So what we are trying is to have the one box solution and really to do all this filtering and operation on the 400 gig side and not on another box. And therefore, we decided to have all the features, which maybe Kubo is famous for, are also available on the 400 gig. Okay, so this is just the summary of that. And yeah, what can we do? Just very briefly, I'm going through is, of course, we can do aggregation. Of course, this is very basic packet broker functionality. Let's say many inputs to one output, one input to many outputs, whatever combination. Of course, we also support the split mode, as we said. So here you see an example. So when the port is 400 gig, it's like looking like this. This is looking when it's 4 times 100 gig. This is what the graphical user interface would look like. Okay, so of course the operating system behind everything is the same as with our 40 gig, 100 gig solutions. It's completely the same. Okay, your typical deployment, let's say here we have the 400 gig inputs, then we're going out here via breakout box, and here we have the 4 times 100 gig physically available on LC connector, for example. And here we could have the monitoring probes or whatever system is connected here. That's rather straightforward. Yeah, we discussed that point. Okay, so no breakout cable. I'm always using breakout box. Okay, as remember, ruggedized, clearly labeled, not just these connectors, which at the end nobody knows what is TX, what is RX, what is the pair number 1, blah blah blah. So yeah, much better like this one. Is this one here? Good. Yo, and as I said, look, we always said we want to do all this packet manipulation, filtering at the input. And then means on the 400 gig side, we have all these filtering possibilities. Yeah. Okay. And there's one thing which I like most is we always can decide about when you have overlay network. Overlay network meaning you have a tunnel on the packet. A VXLAN, GRE, MPLS over UDP, or whatever. Then we always can decide about, do you want to filter in the outer tunnel or do you filter inside the tunnel? Usually people want to filter inside tunnel because tunnel is like more like transport media, let's say, and filtering is usually not relevant. But very often it's inside, and that would look like this. So here's just an example of VXLAN tunnel. So if we want to filter for IP addresses, yes, we can filter here for that. This is the tunnel IPs. Is it really needed? We can do, but we can also filter for the inner IP. And that's something very unique, of course. Yeah. So if, for example, if somebody wants to search for DNS traffic in the tunnel, we can filter for UDP port 53, for example, which defines the DNS traffic directly. We even don't need to strip the tunnel. So we can just do it on the original arriving packet. Okay, so that's that point. And yes, as I said, we don't need to remove the tunnel, but we can remove the tunnels. This is the display actually. Tunnel strip, you just select the checkbox, and then these kind of tunnels by one selection here, of course, you can select even more if you want, then tunnels are removed. So if you are monitoring, maybe it's no good to handle VXLAN traffic, or very often we see now airspan, the people coming out from a virtualized environment, they have these tunnels on the packet, but the monitoring security tool, it cannot handle this tunnel or need some CPU power to remove the tunnel. Hey, we can also do it. Difference is we do this in hardware. Okay, so that's maybe a good release also for the monitoring system to become lower cost, because we are taking a workload away with the packet broker, which this is the purpose of it, of course. Yeah. Okay, so right, this is again the display. You see, we can do it here, or we select the other one, then we filter here, or we filter in the outer tunnel. Yeah, the same is also for load balancing. Of course, the box can load balancing, and believe me, I have an own presentation for load balancing and made a lot of stuff with load balancing. Important is there's different methods of doing load balancing. We have a method just really to ensure that we are session aware. Session aware meaning that the full IP session or TCP session, whatever you call it, always stays at the same probe, so that the probe gets on one physical interface the full upstream and downstream communication. That's actually the goal, and that we can do. There's different things, different mathematics behind, which maybe is beyond that webinar now. But yes, if someone needs some more information, just let us know. And the only thing sorry, this brings me to the end already. Load balancing, there's one important thing to consider is when we go back on this display is, look, what is a session? I mean, if you have a tunnel and you're using the outer IP and say this is the IP session, that means nothing for the inner IP. And inner IP, this is the user, and usually this is the session, is the definition of a session, and not the tunnel. So what we can do is we can do load balancing based on this inner information, so that the real user traffic stays together, and not that the tunnel stays together. Usually, doesn't matter. So we support also that. Right, and that actually brings me to the end. It's just one slide here more. There are many more, but now come to the end is what we also support, and again, is something we do in the packet broker. Is we have a so-called slicing. Slicing meaning when somebody doesn't need the full packet or wants to maybe save some bandwidth and only needs to analyze header information and maybe a little bit of the payload. Yes, we can cut the packet before we forward to the monitoring. Yeah, and this cutting size can be any value. Okay, it's completely free to set. Okay, that's sometimes very good, and we have a lot of use cases where you use this slicing. Not only that people not allowed to see the payload, but also to serve bandwidth. So we're removing parts of the packets that are not needed, just to reduce the bandwidth. So from the 400 gig, easily you can make out a 100 gig, 50 gig even, depending on the size. Right. Good. So it brings me to the last one, and then I'm done. Is look what we have. So looking at that tapping and breakout, packet broker, yes, we believe that there's a lot of high quality innovative products. So we are really focus on that and be part and drive this market. Of course, there's fully passive and transparent solutions. And of course, what is really is this packet broker. Yeah? It's really groundbreaking. Remember, all the features you know of the lower speed product, yes, is now also there for 400 gig. Okay. Right. Good. So this brings me to the end. Paul, I hand over back to you.
Okay, thanks. And Herbert, let me I just need to bring my slides back
no problem.
Up. Can you see?
Yeah, we see.
Can you see my slides now?
Yes, we see.
Great.
Summary.
Okay. So yeah, no, thanks for that. Great. Okay, thanks. No, thanks for that, Herbert. And again, just very briefly, obviously to summarize from a commercial perspective, hopefully you found the technology really interesting, and you would see again that managed investment profile over time, and hopefully you will find that in terms of the very competitive cost of ownership of Cubro's solutions, the ability with a Cubro approach to evolve the migration to 400 gig without that need for that sort of sort of rip out and replace upgrade approach, improve sustainability, but also that sort of future-proof technology that we've built into our solution that helps to deliver investment protection as well. So those are really the key points, I think, in terms of summary. I guess if we move on to Q&A now and see if there are any particular questions that we can answer. Okay, I guess that's no. Is it? Have we got anything, Tamana, that came in during the webinar?
I don't see any questions at the moment, Paul. I think since we are running out of time, probably.
Yeah, I think so. Okay. Okay, well, unless there's any questions, we'll wrap that up there then, I think. Well, listen, thanks everybody for your time and attention today. Really appreciate it. I think the recording is going to be posted on YouTube, and we will send out the invite links to it and so on. So you'll have access to this material, as well as the handout materials. And obviously, if you want to speak to it, speak to us some more about it, feel free to contact us, or indeed any of the other products that we talked about earlier on as well. So thanks again for your time, and hope you enjoy the rest of your day. Cheers.
Okay, thank you, everybody.